What theory best describes everything?
What is the universe? The universe is a symphony of strings. So this is the electron, vibrates this way.
What are the fundamental constituents that make up our world? What is all the matter in the universe made of? What theory provides a description of the physical properties of nature at the scale of subatomic particles? What theory best describes everything? Can there be a theory of everything? American theoretical physicist Michio Kaku is the author of several books about physics and has worked on research on quantum mechanics. He has a unique way of explaining things that make hard concepts such as quantum physics and string theory seem apprehensible to us mere mortals.
What I do for a living is string theory. That's my day job. And you see, string theory is a multiverse theory. So people say, first of all, what is string theory? String theory simply says that all the particles we see in nature, the electron, the proton, quarks, what have you, are nothing but vibrations on a musical string, on a tiny, tiny little string. You know, G. Robert Oppenheimer, the creator of the atomic bomb, was so frustrated in the 1950s with all these subatomic particles being created in our atom smashers that he announced one day that the Nobel Prize in physics should go to the physicist who does not discover a new particle that year. Well, today we think they're nothing but musical notes on these tiny little vibrating strings. So what is physics? Physics is the harmonies you can write on vibrating strings. What is chemistry? Chemistry is the melodies you can play on these strings. What is the universe? The universe is a symphony of strings.
This is the mysterious world of quantum physics. As we explore the strange and fascinating phenomena of the subatomic world, where particles behave in ways that defy our everyday understanding of reality, we will oversimplify these concepts and hopefully you will forgive us for doing so. Because there is nothing harder to understand in science than quantum physics. As Richard Feynman once said, if you think you understand quantum mechanics, you don't understand quantum mechanics. At the heart of the quantum world lies the atom, the building blocks of matter that were once thought to be indivisible. But as physicists delved deeper into the atomic world, they discovered that particles don't behave like the everyday objects we encounter. In the quantum world, particles exist in a cloud of probability. They can be in two places at once and have a mysterious connection that Einstein called spooky action at a distance. To make things even more bizarre, particles seem to be influenced by the observer, as if they are aware of being watched. But that's not all. String theory takes us even deeper into the mysterious world of subatomic particles. According to this theory, particles are not tiny dots, but tiny strings that vibrate at different frequencies, creating the variety of particles that make up our universe. It's fascinating to think that thousands of years ago, ancient Greek philosophers such as Democritus attempted to understand the atomic world using reason and logic.
You know, Pythagoras was a rival of Democritus. Democritus talked about atoms 2,000 years ago, and Pythagoras said, no, music is the language of the universe. So he looked at a lyre string and said, look at the vibrations. Each vibration corresponds to a musical note. The universe is music. The universe is created by vibrating things. Each vibration corresponds to a note. He went to a blacksmith where there were long bars of metal, and they were clanging these bars of metal. He realized that the longer the metal, the lower the note. There's a relationship between the length of the object, its strength, and the note. And then he looked at a lyre string, and he said, the longer the lyre string, the lower the note. And then he said, this is the universe. What explains the diversity? What paradigm is rich enough to explain the diversity of the entire universe? Atoms, but what makes atoms different? And then he said, it's music. But then they never went anywhere, because of course the atomic theory wasn't created for another 2,000 years. But finally, with the atomic theory, we now have subatomic particles. But why do we have so many subatomic particles? They're nothing but musical notes on a tiny, tiny little vibrating string. So this is the electron, vibrates this way. This is a quark. This is a neutrino. So why do we have so many particles in the particle zoo? They're nothing but vibrations on a tiny string.
String theory has also led to some intriguing ideas, such as the possibility of a multiverse, where our universe is just one of many. While this idea is purely theoretical, it shows that the quest to understand the subatomic world is far from over. Some of the greatest minds in science have struggled to understand quantum theory. One of the most notable was Albert Einstein, who believed in a hidden reality that we can't directly observe. He rejected the idea of entanglement, but as experiments continued to prove the validity of quantum theory, Einstein's views became increasingly marginalized.
When I was 8, something happened to me as well. It was in all the papers that a great scientist had just died, and they put a picture of his desk on the front page. That's it, just a simple picture of the front page of the newspapers of his desk. That desk had a book on it, which was opened, and the caption said, more or less, "This is the unfinished manuscript from the greatest scientists of our time." So I said to myself, well, why couldn't he finish it? What's so hard that you can't finish it if you're a great scientist? It's a homework problem, right? Why couldn't he solve it? So to me, this was a murder mystery. This was greater than any adventure story. I had to know why the greatest scientists of our time couldn't finish something. And then over the years, I found out the guy had a name, Albert Einstein, and that book was the theory of everything. It was unfinished. Well, today I can read that book. I can see all the dead ends and false starts that he made, and I began to realize that he lost his way because he didn't have a physical picture to guide him on the third try. On the first try, he talked about clocks and lightning bolts and meter sticks, and that gave us special relativity, which gave us the atomic bomb. The second great picture was gravity, with balls rolling on curved surfaces, and that gave us the Big Bang, creation of the universe, black holes. On the third try, he missed it. He had no picture at all to guide him. Well, today we think that picture is string theory.
String theory also proposes the existence of extra dimensions beyond the three we are familiar with. It's a mind-bending concept that raises the possibility of multiple universes, each with their own set of physical laws. These parallel universes, also known as the multiverse, are a popular topic in science fiction, but they are also a serious area of study for scientists. The idea is that every time there is a decision to be made, the universe splits off in two or more possible outcomes, each occurring within its own separate universe. String theory could also help explain the mystery of dark matter. This mysterious substance makes up around 27% of the universe, but we can't directly observe it. One explanation is that dark matter is made up of particles known as WIMPs, weakly interacting massive particles, which could be produced by the vibrations of strings. While there is still so much we don't know about string theory, it has opened up new avenues of research and shown us that the universe is far more complex and wondrous than we ever imagined. However, string theory, or to be more accurate, the string hypothesis, has also been heavily criticized by the scientific community. One of the main criticisms is that it is difficult to test or falsify it. The theory requires the existence of extra dimensions beyond the three we are familiar with, but these dimensions are too small to be observed directly. Another criticism is that the theory is yet to make any predictions that can be verified through experiments. Despite decades of research and numerous mathematical developments, string theory has not produced any definitive results that can be tested in the lab. Some scientists argue that the theory is overly complex and convoluted, requiring the existence of multiple universes and exotic particles that have yet to be observed. While string theory has the potential to revolutionize our understanding of the universe, it is important to approach it with a critical eye and to continue to explore alternative explanations for the mysteries of the subatomic world.
I would say that any field of research, when it's new, it's going to attract attention, and the news outlets are going to cover it, and students are going to flock to it, sure. But as a field matures, it does shed those qualities because it's no longer as novel as it was when it was first introduced 30, 40 years ago. But you need to judge it by a different standard. You need to judge it by, is it making progress on foundational issues, deepening our understanding of the subject? And by that measure, string theory is scoring very high. Now, at the same time, you also need to judge whether it makes contact with experiment too. And on that measure, we're still challenged. So I would say that many string theorists, myself included, are very sober about the theory. It has the tremendous progress that it had 30, 40 years ago. That hasn't gone away, but we've become better equipped at assessing the long journey ahead.
Thanks for watching. While you're still here, make sure to click the video on your screen for more mind-blowing videos.